Hi, Professor. I'm Benson Fernandez, and we are from Group 2 presenting this midterm presentation for a project, CrowdDoing Preventive Derivatives. Our agenda for this presentation includes introduction, our objective, our team members, the scope of our project, the project's current status, and the challenges that we have faced over the course of our project. We are facing a time where forest health is degrading at a fast pace. So it is important to identify the health of the forest and find possible ways to improve overall forest health. Our client CrowdDoing is a joint initiative company of Reframe and Match for Action foundations, and it mainly focuses on addressing the problems of UN. Moving on to our team consists of three members: myself, the data analyst, and the team lead. Next, we have Jeevitha Murugan, who is the developer of our project, and Jashanpreet Singh, who is the business analyst and mathematician. Our objective for this project is to identify healthy and unhealthy areas to prevent disastrous forest events. As weather is one of the main factors that impact forest health, it is ideal to analyze the relation between forest health and weather patterns. Our client had also requested to devise a formula that can calculate the impact of forest health based on certain weather conditions. We are currently in the development phase where we have started to develop the code that can calculate the health of the forest using weather data. We expect to complete all development activity by the second week of November. Following, we will be having documentation, handing over of deliverables, and project closeout by 10th of December. In our communication plan, we had a total of 3 client meetings till now and a total of 7 internal meetings to discuss about various proceedings for our project. Our next client meeting is on the 17th of October, where we will be sharing the details of development with our client. Over the course of our project, the client had changed the scope a few times. As our initial scope was to use aerial and satellite images along with historical forest fire data to prevent forest fires. The client had then updated our scope to classify healthy and unhealthy parts of the forest using aerial and satellite images by the second discussion. During our third discussion, the client again had updated the scope to add weather analysis to the project and to devise a formula to find the relation between forest health and weather patterns. Next, we will move on to the current status of our project. Our completed tasks include gathering map data, and we have gathered all the map files in the form of GeoTIFF images. Then, we have gathered weather data from 2019 to 2023, as client had requested to focus only on the previous 5 years of weather data. As we do not have sufficient experience in geospatial analysis, we spent quite some time to identify ways to work on the GeoTIFF files, as they are typically huge in size and cannot be viewed in the traditional software available in our systems. We also have received approval from the client for the gathered data and the use of the software that we have found. The software is QGIS, which is an open source software. We have also devised a formula that can calculate the approximate health of a forest based on weather conditions. And this will be discussed for approval with our client in the meeting on 17th of October. Further, we will work on implementing the calculations by the formula over the map so as to give a visual representation and use this to identify health of the forest and its relation to weather. Next, in our presentation, we have the various phases of our project and its details. We started with the recommend phase. During this phase, we have gathered aerial and satellite images for the entire map of Canada. The 4 main maps collected are land cover map, ecological domain map, forest fire map, and tree species map. All these maps are more than 1 GB in size and cannot be viewed using the default image viewer. All these 4 maps show different details and hold different information regarding the forests of Canada. Next, I will hand over the presentation to Jeevitha, who will be continuing the requirement phase.
Thank you, Benson. Hello, Professor. I'm Jeevitha Murugan, the developer of this project. As it is very tediously time-taking process to process the entire map of Canada, we have decided to work only on the province of Alberta after receiving approval from client. We have also collected all the necessary weather data from the year 2019-2023. This data is in everyday format across various geographical locations for that same time period. We have also have the access to the monthly and hourly information, and they will be used if required when needed. From the sample weather data, we can identify the various columns for each locations and the station's names. There is a unique identifier of climate ID. There is like various factors of climate conditions like min and max temperature of the day or monthly or hourly basis, and total rainfall, total snow, total precipitation, and wind speed. These are identified as the important factors considering the impacts of forest health. And as we can see, here is a sample data, which there are some values like running from the min and max temperature, showing us the sample data for some locations. The location is identified using the longitude and latitude of the thing, and it gives us the various data about all the various factors in the table. So similarly, we have the daily records for the past 5 years, which is almost more than 4,000 records for analysis. We have also created some visualizations based on the gathered data of the weather for the province of Alberta. These visuals display an overview about the climate of Alberta for the past 5 years. We have the monthly max temperature, top years with the highest average temperature, and top months with lowest average rainfall. These are some of the key performances indicators which will give us some idea about how the forest health can be affected by the various factors of weathers. Similarly, we can identify as various key factors which will help us to identify more about healthy and unhealthy region of the forest. Moving forward, it is a design phase where we are planning to do how to work on the gathered TIFF images and the weather data. We actually came across the 3 softwares from our research. One is Manifold, and the other one is QGIS, and the last one is ArcGIS. Manifold, even though it is easy to use, but it has a very less functionalities, whereas ArcGIS has various functionalities and most used by the image processing developers, but it is a paid software that can cost us more than $1,000. And whereas we came across one more software called QGIS, which is an open source software, and it is also capable of many features and having an inbuilt console for the Python, and can also use various plugins to process the geospatial images. So using QGIS, we sliced out the different maps of Alberta from the map of Canada. So as we collected 4 types of maps, we have a Land Rover, Ecodome, and 3 species. We have sliced only the Alberta region, and we are able to do it in the QGIS software. And as I moving forward, we identified of various forest classifications in Canada. So we came across a total type of 15 type of forest types available in Canada, and each forest type information is available in the Land Rover map. So each of the mentioned vegetation type consists of its own type of tree and plant types. So the table also consists of the various climatic conditions and the location most suitable for each type of vegetations, and it gives us about the details about the characteristics of each vegetation types and the color coding in the map, Land Rover map. So these color coding will correspond to the in the map it will have the corresponding data. So we also have gathered some of the healthy and unhealthy weather values for the temperature, rainfall, snowfall, wind speed and humidity. So these are the references for these values and they are available at the end of this document. Now I will hand over the presentation to Jashan.
Thank you, Jeevitha. I am Jashanpreet Singh and I am the business analyst for this project. Together with Benson and Jeevitha, we have worked on the slice map of Alberta along with the weather data using the QGIS. We add all the layers of map and weather data using Add Layer option. This adds all the layers to the weather panel and they can be viewed by enabling them. It is important to identify the latitude and longitude format of the maps. Currently we are using the EPSG 3979 and the 4326 standard. In the next step, we select the tabular data and we merge these two layers using the data management tool Join Attributes by Location. We then select both the information and run so that the tabular information is plotted on the map of Alberta. As QGIS identifies the geospatial location for every map, all the maps can be added within this information as displayed in this slide. Now to the next part. We use the Plotly plugin to create some visuals. We have the visual of temperature of Alberta in 2023 as a scatter plot. We have the month-wide distribution of the maximum temperature as here, and we have the month-wise snowfall as a pie chart here. Now to the next part. We have also worked on devising a formula that can analyze the health of the forest by considering various weather elements. There are situations where one weather factor alone does not contribute to the health of the forest. To perform this, we can use a combination of weather factors by using linear interpolation. We add weight values for different weather factors. Adding all these weights should be equal to 1 so as to normalize the process. Next, we calculate the daily values for each of these factors with the allotted weights, and all the values are added to get the approximate value of the health of the forest. We will present this formula to the client in a meeting which is scheduled on the 17th of October. Next, we can proceed to the next phases for the project. The first phase, which will come from now on, is to implement the formula to find the relative health of a forest. And the other step is to prepare a code for the calculation of the above formula that will be implemented on the gathered weather data. Then next we will plot it using the QGIS tool to identify the healthy and unhealthy regions of the forest using a calculated data. These are some of the challenges which we have faced while working on this project. There was no data provided to us by the client, because of which we had to search intensively for aerial and satellite images. As those images data are not easily available in public, we had to spend quite a lot of time on that. Furthermore, we did not have an expert from the field of environmental science who could validate the formula we have calculated. As the client was really insistent on getting someone who is an expert in environmental science, the project was delayed by a few weeks. Only on our urging did the client agree that we should proceed with the project. QGIS is an entirely new tool and effort has been put to learn the tool before implementing the project in this tool. We have the scope changed a few number of times, which had us rework the most of the elements of the project at each point in time. Now I will move on to the budget of the project. We have adhered to follow the budget, but due to scope changes and reworks, we had a significant increase in the actual hours the team had invested in this project. Here are the references from which we have taken our weather data and from where we have searched how to devise the formula for healthy or unhealthy forests. This concludes our presentation, and thank you for your time.